All right, so today we're going to look at our last lesson in probability. This doesn't mean you get to forget it after this. It just means we'll be moving on to different material. So we're going to look at one other way that compound probabilities are displayed, and that's using what are called two-way frequency tables. Frequency just means how many times something occurs, and that's why it's called a frequency table. It's just these are usually just known as two-way tables. All right? So, two-way tables because they give information in two different directions, and the actual piece of information that you need, is actually in the middle, the intersection of those. So in this particular example, students are using Instagram and using Snapchat. So the intersection of those two things is where they're doing both things simultaneously. Yes? Okay? So pay close attention when you're reading these. Make sure you're on the right column or the right row. Remember, columns go up and down, rows go across. All right. Now, one thing that this particular chart is missing is something that is critical in order to make these happen. And you'll see that they added in a moment. Go down a little bit further here, and you'll see that they've added totals. A column for totals and a row for totals. And this spot here is always the grand total of every single person in the study. The other totals are simply totals of either the rows or totals for the column. Yes? But these numbers need to add to this number, as well as then going up and down, they need to add to that number. So you be careful with your math. Make sure that, because most of the time you're going to have to fill in missing pieces of these. So make sure that your math agrees by checking this grand total that becomes the same up and down as well as across. Okay? Now, again, most of the time they're not going to give you these totals, or they'll give you some of them, so you're going to have to figure out the rest. Right? But let's say, for example, that I knew the total, that this was 714 and this was 500. How could I find this number if I didn't know it? Simply subtract, right? Find out what's left. Yeah. Okay? So if I didn't know this number, but I knew these two, again, same thing. I could subtract one from the other to find out how much is left to put in the last box. So pretty easy to find them. What if they didn't give me this 500, how could I find this number if I didn't have it? Simply take this one and what? Add them together to get the total, right? Right? Good. So keep that in mind. This one is completely filled out for you. That's not usually the case. You're usually going to be given some blank spaces that you'll have to work with. All right. Now, using the chart is really straightforward. But you might wonder, why do we have two-way tables for some questions and then probability trees for the other ones? And the answer is actually in the name. Those are probability trees. Therefore, we know the probabilities of the items that we're working with, right? But these are frequency tables. So I don't know the probability, I just know how many times something happens. So there will be times when you're going to be working through some of these problems, and they won't tell you whether to use a tree or a table. You have to decide. And so what if I say that the probabilities of doing something is, 3/4? If I give you a probability, then which one should you use, the tree or the table? Tree, probability tree, yes? Okay. Then if I just told you 30 people did this, then that would be using a table, frequency table. Okay? So that's how to remember which one to use. Generally they tell you, but they don't have to. They can sneak one in where they just let you decide. Okay? All right. So we have our tables. These totals are one of the most important pieces, because if you'll recall that the probability of an event is all of the successes over every possible outcome. So these totals are the possible outcomes, the total possible outcomes. So those are the denominators of your probability. Okay? Now, but notice there are lots of different numbers. So you have to be very careful to decide if I'm talking about everyone in the sample. If that's the case, then that's this grand total at the very bottom. Or am I given what's called a conditional probability? In other words, they have to do this, so I'm only allowed to look at those students. For example, I could say, of the students who use Snapchat. So is that everybody? Nope, it's only the ones who what? Who use Snapchat. So I'm only, let's go to this one. So I'm only allowed to consider these numbers. So what would my denominator be in that case? The 500. Okay? So be careful. What if I said a random student? Is that out of everybody? Yeah. Absolutely. Right? So be very careful about which total you're using. And this is a great example because they're going to give you one of each scenario, a couple of each scenario actually. Okay? So let's just go through, have that handy because when I scroll I'm going to lose it. Okay? So what is the probability that a student uses Snapchat? A student. So is that a specific group? No. Nope. So that means everybody. So that means I'm going to use the denominator of 714, right? And uses Snapchat. That's this column. So simply 500 out of 714, which of course they rounded to 4 decimal places. All right? So it's very straightforward. The tables are designed to make your life easy. So let it. But in order to do that, you really have to be careful about reading the question. Right? Just make sure that you know which pieces to use, and it's quite easy. Okay? So here, what is the probability that they use neither Snapchat nor Instagram? So we want to know that they don't use either one. Okay? Well, so if it's in the category of uses Snapchat, I can't include anybody in this line, right? Because they use it. I can't use anybody here because they use Instagram. So that leaves me with how many students? 168. Out of everybody? Yes. Okay? So many times when you're using these, it's easier to just exclude the ones you don't need, and that'll tell you the ones you do need. Okay? All right. If 2 students from the school are selected at random, what's the probability that they both use Snapchat? Okay, now be careful here. We're going to pick a student, and then we're going to pick another student. So that's an and statement. So what does that mean I'm going to do to the 2 probabilities? Multiply. And rule is multiply. Good. And if I pick a student, would I be choosing that same student again? No. So what's that going to do to my numbers? It's going to reduce both numbers, both the top and number by 1 student. So you'll see. So it uses Snapchat. There were 500 students 500 students out of the 714 that used Snapchat. But then look at the next numbers for the second student. So this is for the first student. For the second student, we had to reduce those numbers because one person has already been chosen. We can't choose that person again. Now here they did not say without replacement, but remember we talked about that yesterday. Think about the scenario. If I already choose one student and ask them, do I want to then throw them back in the pool and then ask them again? Doesn't really make any sense, does it? So pay attention to the context of the question to see if it is with or without replacement. Okay? So be careful about that. Then, if an Instagram user is selected at random, so this is an example of the conditional probability. We are only being able to consider those students who use Instagram. Yes? What is the probability that he or she also uses Snapchat? So, uses Instagram is the column that we'd be working with. And we want to see if they use Snapchat as well. So it would be 382 out of 428. Yeah? So be careful. If they give you a condition that must be met, you have to think about that first. Okay? All right. Now, compare the answers to A and D. What do they tell you about the users of Instagram and Snapchat at the school? So, A, that's just the ones who only use Snapchat. D was the ones who use both, right? Okay? And what do you notice? 7.03, 8.04. So that means that if they use Instagram, they are also more likely to use Snapchat because the probability went what? Up. What if it stayed the same? Then they're just as likely to not, right? Okay, if it went down, then they would be less likely to use it. Okay? Now, do notice that when they talk about this, though, they use the probabilities. So if you are going to answer a question, remember it's still a math class, you must use numbers in your definitions and explanations. All right? You don't have to show me the calculations again, but you do have to tell me the probabilities, right? This one is higher, this one is lower, whatever. Okay? How does that look? Nothing too new there, yeah? Okay. Then, so we have, let's see how much they give us there. So 1, 2, 3, 4, 5, 6. Oh, they love these things. So 6 of these. Now, I'm going to tell you that I want you to do the odd numbered ones, but you might look over some of the even ones because they may throw in a wild question here or there. So just be prepared that the odds might not prepare you for everything, but should be okay. All right? So there you go.